So thank you very much for the invitation to participate in this ETSI SDG Ecosystem Day. I'm Antonio Elizondo. I'm working as a chief architect of the telco cloud within Virgin Media 2. Okay, and I'm going to talk about a proof of concept that we have done on intent-based orchestration using OSM, okay, and this has been used for our private telco cloud. Before jumping into the presentation, as I will do a demo, I'm going to start some steps on that. Sorry. Well, this is a workload cluster in our testbed environment, okay, this one, okay. Where I've deployed some minutes ago, 40 minutes ago, an application that is well known. Jenkins is a continuous integration tool, okay? And well, probably many of you, if you are familiar with Kubernetes, okay, this is the pod running. And you know that Kubernetes is providing orchestration capabilities. This has been deployed, as you can see here. Let me, this is in the owner reference, you can see that this has been deployed by a replica set. And if you look for the replica set, you will see that this has been deployed by a deployment. Okay, so those who are familiar with Kubernetes probably will know that if I delete this pod, okay, it will be finally recreated, okay? And if I delete the replication set, it will be recreated by the deployment. But how about if I delete the deployment? Or how about if, well, give me a second, because this is starting again. Shouldn't take too much, typically. Meanwhile, I'll continue with the presentation. Okay, allow me to mention that the telco cloud that we are talking about in Virgin Media 2 is a horizontal virtualized private cloud infrastructure. Okay, where we are hosting network functions, also called VNFs. Okay, but also CNFs, because we use that term for distinguishing between virtualized and containerized things. Okay, one of the fundamental things is that these VNFs are provided. We are multi-vendor in the sense that we consume products from different network equipment providers such as Ericsson, Nokia, Mavenir, Oracle, Matrix, and many others. No? Okay, so this is why it's a horizontal platform because it is not dedicated to just one vendor or one application, but it's a sort of cloud that can use to deploy many different workloads. Okay, the goal is simplifying the operational model, very aligned with the original SCNFB objectives. Okay. And this platform is key for the implementation of the 5G core. Okay, indeed, we in this telco cloud we are running services like the IMS for both the fixed and mobile business. Okay, we are running a lot of different signaling elements like NRF, SCP, CPP, and many others. The charging gateway, the policy consumer function, JLAN services, and many other things. Okay, this is based on the telco cloud on SCNFB architecture. Okay, and we are using OSM, the open source manual, to orchestrate both VNFs and CNFs. Okay, and we are managing more than 3,000 servers distributed in different sites. No? As you can see, everything in United Kingdom. And this was launched in 2021 and is live from 2022. Okay, and it's a strategic internal program. So allow me to change again because I guess that the pod will be up and running. Okay, if we have a look at the services, we can see that it's exposed here. We will see that we can reach our Jenkins service. Okay, but as I was commenting, if we delete, for instance, the deployment or the whole namespace, okay? Let me delete it. Well, the normal thing in Kubernetes is that we have lost the application, okay? Indeed, after a while, if I try to reload, I will have problems. Okay, indeed, you can see here that it is not responding, okay, and it will be deleted. So that's something that, let's say, Kubernetes is able to orchestrate things like, keeping the pods healthy, but if you accidentally delete something like a deployment or namespace, then it's lost, okay, and you need to redeploy the application. So this is connected to what I'm going to describe here. Okay, so allow me to talk about some challenges that we have in an operation like Virgin Media tool that is multi-vendor. One of them is that, we want to adopt modern ways of working like CI/CD. Probably many of you have heard about that, but the thing is that these approaches are typically followed by companies that are somehow controlling and developing their own stack, their own software, their own code. Okay, so it's something more difficult to adopt for, if you think twice, for an operator that is consuming products from different from the different vendors. No, we don't have access to the source code. Okay, open source manual and open source projects, of course, are an exception. Okay, then we cannot customize too much. Everything is depending on what the product is offering to us. It's a sort of black box for us. And the upgrades, although many of these vendors are advancing to be more cloud native in the products, they are not so often, they are not done so often as probably they should, or in other parts of the software industry it is done. Okay, so what should be our approach then? How to, because we cannot be just an extension of the CI/CD pipelines that, of course, our vendors have. Okay, because that will be very expensive, and non-scalable and very difficult to operate, to have to adapt to these different multiple vendors that we have. Well, the approach is treating these products as they are, black boxes for us, and ingesting the artifacts, validating them, both from a security perspective, scanning them with malware, tools, whatever, doing compatibility testing, functional testing, whatever, and finally, trying to deploy. Okay, well, sounds easy, but it's not so easy to do. Okay, it's easy to say, not so easy to do. Apart from that, how can we use much more modern things like the GitOps things or intent-based orchestration? Well, in this scenario, if we just try to do the traditional CI/CD approach, where we will be pushing to our environment the things that are provided to us by the vendors, well, obviously, it is risky because we don't have the control of exactly what has been provided. Okay, we need to work with all the different vendors. In case that there are drifts in the running configuration, then we need probably to first of all, understand what is the drift, and then do the manual enforcement for getting back to the thing. Then how to do the audit, investigating the logs in the whole CI pipeline, and the approach is flexible, but it needs to be integrated with many of them, and it's difficult to do. Okay, what are the advantages of implementing a sort of a GitOps approach, where instead of pushing the changes, the cluster, okay, the Kubernetes cluster is pulling and looking for changes on the intended configuration? Well, the security risk is lower because we will be using Git for tracking the changes and approving them, using it as a sort of a guardrail. Then is more, obviously we cannot use it for everything if a VNF comes, so it's not very cloud native, and probably we cannot adopt this model so well as in the case of CNFs, okay? Then we have the benefit that if somebody does manual change accidentally or whatever, then we have the auto-reconciliation because GitOps will be pulling the changes and change that, no? And it's also easier to audit any change, no, in the configuration because all the changes should have been approved, merged and approved, okay, in the Git server, okay. And well, this approach is more standardized. That is something that probably will help us. Obviously, it won't be so flexible. It will have some rigidity, but probably all the pros that this GitOps approach have are worth for an operation. Okay, so what is our vision about that? Well, let's that the continuous integration pipeline focus on the pre-validation of these artifacts provided by our vendors, okay, as if they were just black boxes, and let's base the continuous deployment on GitOps approach, okay, taking advantage of everything that I've mentioned before, okay. So, well, the benefits of this is that the intent-based deployment will help us, no, on making more declarative configurations, so not dealing with low-level details that can lead easily to errors, inconsistencies, and at the end increasing the cost of operate an environment like this. Okay, so in this way, the intent-based or GitOps way, okay, will make that the Git server where the configuration is hosted, this will be working as the source of truth. Okay, and basically the technology problem to solve is how to make that how to observe how to distinguish what are the drift changes, okay, and produce the necessary adjustment to comply, no, with the intended reality, with the intended configuration. Okay, so this is how the schema will look like. Okay, so basically a CI pipeline, traditional one, where we are doing all sorts of functional and security verifications, and then pushing everything to these Git servers that will act as the source of truth, and with mechanisms like Argo city, Flux city, we can implement the continuous deployment pipeline, okay, and being able to make sure that the applications that we are deploying on the infrastructure are following the configuration that we wanted, and not the one that somebody has tried with probably with his best effort, okay, and is willing to implement. Okay, give me a second because this is not working. Okay, so is this as easy as it sounds? No, it isn't. Okay, because let's say basic GitOps is not enough. Okay, so a new Kubernetes cluster needs to be ready before attempting to deploy any application. So there are many low-level steps that needs to be done. Okay, bootstrapping all the different things is not evident, and let's say can be done if you have a lot of engineers working on that and coding all the low-level things. Okay, so you need to make sure that the CRDs and the operators are needed, are ready before the application is installed and ready to use it. The databases typically are hard to manage because they require stateful, and well, at the end of the day, this needs to be organized. Okay, then avoiding doing massive duplication of intents and making integration as simple as possible. That's also something that requires a lot of effort. Okay, well, at the end of the day, bootstrapping these remote clusters that are going to be integrated and managed by a GitOps approach, okay, is not something easy to do. Okay, so here is where OSM is coming to the rescue, because OSM has been working since the last versions in adopting a model that goes beyond the declaration of enforcing the configuration, but is more a model for declaring the high-level intents of what needs to be deployed. Okay, so at the end of the day, these high-level intents that are easily fed to OSM. The OSM, what does is decomposing that into very low-level intents. Okay, so that is making that the effort of doing the onboarding of an application is relatively slow. Relatively low, and what OSM does is, well, at the end is reducing the manual work of working and managing different manifests, okay, because you don't need to deal with many low-level details, okay, that will be translated automatically by OSM because it has a well-thought and structure of different layers that that are helping to produce the necessary abstraction. Okay, so the intents will generated with that will conform always to best practices in terms of security, maintainability, and reusability. So the onboarding engineer doesn't have to deal about that. Then, well, this GitOps approach will provide, will minimize the errors. Also, this intent-based approach helps to put very clear what is the necessary synchronization orders. Imagine that you are deploying a database application. So first you need to deploy the internal database, and then after that the front end that is consuming that. Okay, then well, all of that comes with a lot of benefits from a real operation. Okay, so this is how OSM looks like behind the hood. Okay, so basically there is a source of truth that is a Git server. Okay, whatever. Then we have an OSM management cluster that is using Flux CD technology to understand any change from the Git server, and this OSM management cluster has been onboarded with different Kubernetes clusters. Okay, that is managing and is observing any difference. Okay, well, what are the expected benefits of an approach like that in summary? Well, standardized deployment procedures, streamlining cluster management, continuous reconciliation, error reduction. So any manual intervention will be automatically revoked if it is not following the right path that is contributing and approving the change on this lab server. Okay, and improve disaster recovery and time and effort savings. Okay.
Antonio, we should wrap up if this is not your last slide. Okay, thank you.
So at the end, what is this providing? Resiliency of the service is radically improved. Okay, so I started deleting a pod. That is something that Kubernetes does. But well, what if a secret is deleted? What if a config map is deleted? A deployment, an MSpace, a Kubernetes cluster? Okay, well, all these cases can be covered. Okay, and just to show you the outcome of this, you will see that I deleted this 11 minutes ago, as you can see. This has been created 11 minutes ago. When we started, it had been deployed like 20 or 40 minutes. I don't remember exactly. And you can see now that our Jenkins is already alive. Okay, so basically, this is paving the path to, let's say, to have much more robust operations that we have, preventing any human error, okay? Because well, an orchestration, an intent-based orchestration like the one that OSM is able to provide, will help us to correct the things on real time, as you have seen in this demonstration. And that's all that I wanted to share with you. Thank you very much.